Evaluate the integral. Answer exactly. Here we have a definite integral from 0 to 1 of dx over 1 plus x squared. So in this situation, what we need to recognize is the form of this integral is that of our arctrig functions. We have a rational function, and that sometimes will indicate that we would use a logarithm to integrate, but in those situations what you need is the numerator to be the derivative of the denominator. The numerator here is just effectively 1 times dx. The denominator, clearly, if you take its derivative, that's not just 1. So we need to know these formulas in order to work this through. And we have to decide which one this fits best. So there's no square root in the denominator, so that rules out arcsine and arcsecant. So arctangent's really all that's left. And if you'll notice, 1 over u squared plus a squared. So a is the constant, so a is equal to the square root of 1, which is still just 1. And u, that function, is going to be the square root of x squared, which is x. And the important thing is to make sure the du matches up as well. So du is going to be the derivative of x, so dx. And that's exactly what we have in the numerator, so we're all set there. So when we integrate, there's not much to this. We're just following a formula. The formula says it's 1 over a, so 1 over a is just 1. Go ahead and put it in for emphasis, times the arctangent of u over a. U is x, a is 1, so this is just x, and then that gets integrated from 0 to 1. Now, when we actually evaluate the definite part of this integral, we're using the fundamental theorem. So we would take the arctangent of the upper bound 1 minus the arctangent of the lower bound 0. And if you're not familiar with how to evaluate arctrig functions, that's fine. You can draw out a unit circle, or you can use the calculator. You do need to get exact answers. Exact answers here mean radians. Make sure you answer in radians. But the thing is, when you're doing an arctrig function, the result is going to be a angle measure. And it's going to be easier to identify what angle measures you're working with initially in degrees. So I would recommend go into the mode settings and make sure you're in degree mode. When you're in degree mode, now so second and tangent would give you an arctangent of 1. And so that tells you it's 45-degree angle measure. And you should know that 45-degree angle measure is equivalent to pi over 4. And if you aren't versed in that, just remember, effectively, if you take 45 and put it over 180, and just reduce that fraction. So be it math, frac. It's 1 over 4, and then for radians, just throw in the pi. So it's pi over 4. So anyway, arctangent of 1 is pi over 4. Arctangent of 0, that should be pretty recognizable to you as just 0, but that's okay if you need to use the calculator, of course. Either way, the final answer here is pi over 4.